Good day. I will now discuss planes in space. So we have here the definition of planes in space. Planes determined by a point and a normal vector. A plane in free space can be determined uniquely by specifying a point in the plane and a vector perpendicular to the plane. A vector perpendicular to a plane is called a normal to the plane. So geometrically, so we have here a plane drawn in the XYZ axis. And this plane is represented by the Greek letter rho. If we have a point P sub O, which is the initial point, and the terminal point P on your vector, and we draw a line or a vector perpendicular to vector P sub OP, so this normal vector is also perpendicular to the plane. So with that, we now have the equation of the plane in three space determined as we have here. To find an equation of the plane passing through P sub 0 with coordinates x sub 0, y sub 0, z sub 0, and perpendicular to the vector n, whose components are a, b, c, define the vectors RO and R as RO equals x sub 0, y sub 0, z sub 0, and R equals xyz as its component. So if we're going to look at the figure again, so R sub 0 is, we have here the vector from the origin connecting with P sub OP. So we have this. So this will be your R sub O. While for R, vector R, it is obtained by connecting the origin to point P. So that is your vector R. And the components of R sub 0 and R can easily be obtained by getting the difference of the components of the initial points to the, or rather the terminal minus the initial point. So in R sub 0, we have the coordinates of P sub 0 as x sub 0, y sub 0, z sub 0, while the origin will be 0, 0, 0. So obtaining now the difference of their coordinates, it will give us the component of your R sub O equals x sub 0, y sub 0, and z sub 0. Then if you have point P, whose coordinates we have it as x, y, z. So we have here also now this vector R determined from its initial point at the origin. So we can define the component of your vector R to be the difference of initial point P to the origin. So this gives us x minus 0 is x, y minus 0 is y, then z minus 0 is z. So that's why we have here vector R is equal to components x, y, z. The plane consists precisely of those points P for which the vector R minus R sub 0 is orthogonal to vector n. So meaning R minus R sub 0 vector is perpendicular to vector n, which we can represent this as P sub OP. So this is now R minus R sub O. So it's orthogonal to n, or expressed now as an equation, and that quantity R minus R sub 0 equals 0. We know that if we have the dot product of two vectors equals 0, then they are said to be, the two vectors are said to be orthogonal or perpendicular. So with that, we can now write the vector equation in terms of components as for vector n, whose components we have it as a, b, c, that product with the vector r minus r sub 0. So r minus r sub 0 will be the components of your vector r x, y, z minus the components of your vector r sub 0. So this will give us x minus x sub 0, y minus y sub 0, then z minus z sub 0 equals 0. Then if we're going to get now the dot product of these two vectors, we'll now have this following equation: a multiplied by quantity x minus x sub 0 plus b multiplied by y minus y sub 0, then plus c multiplied by z minus z sub 0 equals 0. So this equation is called the point normal form of the equation of the plane. We can reduce the point normal form of equation of the plane. So from the equation that we have seen a while ago, we have a multiplied by quantity x minus x sub 0 plus b multiplied by y minus y sub 0 plus c multiplied by z minus z sub 0 equals 0. So this is obtained by using this theorem. It says here, if A, B, C, and D are constants and A, B, and C are not all zero, then the graph of this equation, the point normal form, will be reduced to AX plus BY plus CZ plus D equals 0. So this is a plane, equation of a plane that has vector n equals ABC as a normal. So to show you the reduced equation, how do we obtain this reduced equation? So we can perform here expanding this equation as we have here ax minus ax sub 0, that's multiplying a and x minus x sub 0 plus b times y minus y sub 0 is by minus by sub 0, then plus cz minus c times z sub 0 equals 0. So we can now combine ax plus by plus cz, and then the constants here, negative ax0, negative by0, and negative z sub 0 will represent our constant d. To summarize the equation of the plane, so we have here the plane through p sub 0, whose coordinates are x sub 0, y sub 0, z sub 0, as we can see from the figure, normal to n, meaning perpendicular to n, whose components or n equals ai plus bj plus ck, or it's also equal to abc in bracket form, has this vector equation and that e sub op equals 0. Then the component equation of plane is a multiplied by x minus x sub 0 plus b multiplied by y minus y sub 0 plus c multiplied by z minus z sub 0 equals 0. Don't be confused on the letters used here. It's capital letter A, B, C. It's also the same as when you have small letters A, B, C. Then for the component equation simplified, it is ax plus by plus cz equals d, where d is equal to ax sub 0 plus by sub 0 plus cz sub 0. Let us work this equation, or rather this example. Find an equation of the plane that passes through the point P and has the vector n as a normal. So we have here given point P whose coordinates are 1, 1, 3, and the normal vector whose components we have here given as negative 1, 7, 6. So to solve for the equation of the plane given a point and a normal vector, so we'll make use of the formula, the point normal equation of the plane. So we have a multiplied by x minus x sub 0 plus b multiplied by y minus y sub 0 plus c multiplied by z minus z sub 0 equals 0. So our A, B, C will be the components of your vector n equals negative 1, 7, 6. So A is negative 1 multiplied by x minus x sub 0. We have the coordinates of your point P. We have it as 1. Then plus B is 7 multiplied by y minus y sub 0 is 1. Then plus C, which is 6 multiplied by c minus 3 equals 0. Simplifying, we get now negative x plus, you have it as 7y plus 6z. Then you have positive 1. Then you have negative 7, that's negative 6. Then negative 18, that's negative 24 equals 0. You can also simplify this in another way. So multiplying both sides by negative 1, this will be x minus 7y minus 6z plus 24 equals 0. So this is the answer for problem number 1.